Hello and welcome to Mathematics with Simon. Today we're going to look at the modulus sign in A-level mathematics. So this is what it is, the modulus function. So modulus of x is always positive or 0. In fact, we should say that because it can be 0, positive or 0. If x is greater than or equal to 0, then modulus of x is just x, and if x is less than 0, then modulus of x is minus x. So basically it looks like this. As x rises, modulus goes up as a straight line, y equals x, and then as x falls, it goes up as y equals minus x. So it's a lovely V shape. It's also what we call an even function because it has symmetry around the y-axis. And it has a corner at the origin, which is not something we've seen before. It's not something you see in a polynomial, like x squared, x cubed, x to the 4. Something a bit different. So firstly, thinking about solving equations with a modulus function. So let's say we need to find an x such that mod x equals 2x minus 6. It's actually very interesting. Okay, let's first assume that x is positive. So that means that we're going to use mod x as x. So we've got x equals 2x minus 6. We take x from both sides. We add 6 to both sides. We get x equals 6, which works because 6 is a positive number. Then let's assume that x is negative. So then you've got minus x equals 2x minus 6. Then we add x to both sides and add 6 to both sides, and we get 3x equals 6, x equals 2. But that doesn't work because that's not a negative number. And here's the visualization of it. So this at the top is the modulus line. And then this line here is 2x minus 6. And they are just hitting here at 6. But they're not hitting anywhere else. It's very pretty. And what we sort of notice here is that the intersection of a straight line with the modulus function, it can intersect once, twice, or no times, actually. It depends. And to be honest, when we're solving these equations, there's an algebraic way, but it's also important to draw the picture just to make sure we haven't missed anything, I think. Here's another one. Mod x equals x over 2 plus 2. So firstly, let's assume x is positive. Then we get x equals x over 2 plus 2. Take x over 2 from both sides. That means x over 2 equals 2 times by 2. That means x equals 4, which works. It's a positive number. Next, we're going to look for negative solutions. So we get minus x equals x over 2 plus 2. Take x over 2 from both sides. Minus 3x over 2 equals 2. Times through by 2, divide through by 3, x equals minus 4 over 3, which is negative, so that also works. And here are the beautiful lines that show how that solution works. So right here we've got the two lines crossing at 4. Is that what we said? 4? Yes, it is. Next we've got the two lines crossing at minus 4 over 3. Is that what we said? Minus 4 over 3? Yes, it is. And we can't see it's exactly minus 4 over 3, but it's a bit bigger than minus 1 and a bit less than minus 2, and it's closer to minus 1 than minus 2, so it is minus 4 over 3. And isn't that beautiful, the way we can do the algebra and then look at the picture as well? Here's another curve. This is awesome. Y equals mod x plus mod x minus 3. So this is fascinating. We've got two corners. It's got a flat bit. So here, if you wanted to look for the solution of mod x plus x minus 3 equals 3, you've actually got a whole range of numbers for which that's a solution. Now what's going on here? Let's put in some example numbers. So if we put in minus 4 in here, we're getting 4 plus 7. We're just getting 11, which is why that's that. If we put in 0, we're getting 3. If we put in 1, we're getting 1 plus 2, which is 3. If we put in 2, we're getting 2 plus 1, which is 3. If we put in 3, we're getting 3 plus 0, which is 3. If we put in 4, we're getting 4 plus 5. 4 plus 1, which is 5. 4 plus 1, which is 5. That's why that is that. Beautiful shape. So some final thoughts about modulus. This function has corners, and when you learn about derivatives, if you know about derivatives, we'll know that that's a place where there's no derivative. And the reason that's happening is because it's defined in segments. That's what's allowing us to have those corners. So there's the positive segment and the negative segment, and it's a different algebraic function in different segments. The fact that it has corners actually proves that it cannot be represented by a polynomial. There's no polynomial representation of it because every polynomial is differentiable at all points. A polynomial is just x, x squared, x cubed, x4. These are quite advanced ideas. If they're hard to follow, don't worry. It'll all fall into place later in the A level. What's also interesting is the kind of modulus or magnitude concept. It also applies to complex numbers and vectors. So in each case, it's kind of the length of the line from the origin to the complex number, or the length of the vector. It basically says you neglect direction and just think about length. And that concept works for real number modulus, which is what we're looking at now, but also the same ideas with complex numbers and vectors. Thank you. I hope you liked the video. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.